Hello guys, in this video we are going to see more basic methods in integral, in this case trigonometric integrals. The objective is to understand or know how to solve trigonometric integrals, a very specific type, okay? We are not going to see changes of variables or this kind of solutions. We are going to just apply the chain rule with sine or cosine only, okay? What are we going to need? Some notions of integration and calculus, and we will need to simplify some expressions, but not so much, okay? Come on, let's see. In this case, we are going to review these two formulas, the ones you see on the screen. The first one is, what happens if I have the sine function only? Be careful, I'm not talking about sine squared or square root of sine, or sine only. Sine of a function, something in between the sine and the derivative of this function outside. Be careful again. Only the derivative of the function between parentheses. I'm not talking about the derivative of sine of a function, okay? It's just the derivative of whatever is inside the parentheses. If you have this pattern, then the integral is negative cosine of the function f, okay? The other way around. What happens if I have cosine of a function and the derivative of this function is outside? Then what I have is sine of this function. The derivative must be there just to apply the formula only, okay? The derivative won't appear on this side. So remember, sine of a function and the derivative is outside, negative cosine of the function. If I have a cosine of a function and the derivative is multiplying outside, then this is sine of the function, okay? As a specific case, when the function is just x, I got these two formulas that probably you know already. The integral of sine of x would be negative cosine of x, and the integral of cosine of x is going to be sine of x. This makes sense. Why? Because the derivative of negative cosine is sine, and the derivative of sine is cosine, okay? Remember that you can just check if the solution you find is correct or not, okay? Come on, let's see, let's continue. Example. Someone asked me to integrate sine of 3 times x. Then what should you do? First, recognize that this sine of a function. The function is 3x in this case. And the question you need to ask yourself is the derivative of 3x outside? The derivative of 3 times x is 3. It's here. Perfect. So I can apply the formula. The formula tells me that this is negative cosine of 3 times x. Okay, so look at the pattern, sine of a function. If the derivative is outside, then the integral is minus cosine of the same function I had before between parentheses. Nothing about the derivative, okay? Please remember that. Another example, piece of cake again. Cosine of 2 times x times 2. What do we see here? Cosine of a function. Which function? 2 times x. Question, is the derivative outside? Yes. The derivative of 2x is 2, so I got it here. So I can apply the formula. I have a cosine of a function and the derivative is outside, so this is sine of the function I had between parentheses. Piece of cake, piece of cake. What happened with these integrals that you normally get confused with what to write in here between parentheses? In here, you are going to write exactly the same function you see on the blackboard, on the screen, okay? So come, let's see another example. Sine of x squared times 2 times x. Perfect. Do you see the pattern? Sine of a function. The function now is x squared. Question, is the derivative outside? The derivative of x squared is 2 times x. So the answer is yes. I got everything. So the solution of that is negative cosine of the function between parentheses x squared. Okay, piece of cake. Another example, a little bit more complicated this time. Cosine of a square root of x. And now the question is, okay, I see the pattern. Cosine of a function. Is the derivative of the function outside? Is the derivative of a square root outside? Then you need to breathe a little bit and, okay, which was the derivative of a square root of x? The derivative of a square root of x, by the way, it's just 1 over 2 times the square root of x. You can just solve it in many ways. One way to solve it is x power 1/2. The derivative of x power 1/2, the 1/2 goes down, then it becomes x power minus 1/2, and then you can write it this way. But in my opinion, it's better if you remember that the derivative of the square root of x is 1 over 2 times the square root of x. So I got everything I need. Cosine of a function, and outside I have the derivative of this function. Perfect. I can apply the formula, and this is just sine of a square root of x. Remember, the function between parentheses, okay? It's done. Piece of cake. I hope so. Another one, but now something is missing. The same example as before, but missing something. Sine of x squared. I see the pattern. Sine of a function. The function is x squared. Is the derivative of x squared outside? The derivative of x squared is 2 times x. Okay, I have x, but I don't have 2. If x was missing, it's a completely different integral. Could be much more difficult. But if x is there and the only thing missing is a constant, I can solve it. How are we going to solve it? Very easy. Okay, I'm going to multiply by 2 the x inside the integral, and I'm going to compensate this with 1/2 outside. Okay, now the integral have everything I need, sine of a function and the derivative outside. So it's going to be, oh, look, I made a mistake. 1/2 should be written here, should remain 1/2 here. And the integral of sine of x squared times 2x is negative cosine of x squared plus c. So be careful, I need 1/2 in here, okay? So what have we seen? We just review trigonometric integrals. They are not complicated, but to see the pattern or recognizing when we need to apply these formulas, it's tricky at least. Okay, so I hope you find this helpful, and thank you for your attention, guys.